The last time that we went on our organic chemistry to date, we basically ended up with this example, and I gave you some homework. Imagine your date giving you some homework saying, do this before I see you next. Could you imagine? Okay, so maybe some of you have had that happen, or maybe some of you do that on your date. I don't know. But this example said, draw a structure for each of the following, and it gives me A, B, C, D, E, F. So I'm supposed to use the rules that I have learned with the dye-substituted benzene nomenclature lesson in order to answer these examples. All right, so let's just tackle them one by one. And we'll start with A, and we'll go through and we'll answer each one of them, and we'll double check your answers to see if you did them correctly when you did them on your own, because I know you did them on your own, didn't you? All right, so let's start with A. A says M, and then chloro, then methyl, then benzene. Okay, so here's the story. I know that these questions are going to ask me about orthos and metas and paras, so I'm just going to come over here one time, and I'm going to scribble myself a cheat note. And this cheat note is going to say, all right, if I have something that is right here on a benzene ring, well, we've already talked about many times O, M, P, Becky. All right, so there's our ortho, there's our meta, and here is the para position. So for part A, it gives me M-chloromethylbenzene. All right, so what that means to me is that I'm going to draw the benzene ring, and it doesn't really matter which one I start with, chloro or the methyl group, so I'll just start with chloro first because that's what they've written in the name first. And then this is a meta position. So if I take a look at the way that I've just done this template, here is the component that I know, and meta is going to be at this location. And this is a CH3 group. Folks, there you go. That's all that this example question is basically going to ask us to do. So then we go to B, and B says P bromo phenol. Oh, okay, so here it looks like they're using a common name, which is no big deal. We've talked about this before, so I'll start with my benzene ring. And the benzene ring is actually a phenol, which means it's a benzene with an OH group, right? We said that that was phenol. That was a structure that you should memorize. Well, this P basically means para. So para, OMP, means directly across from each other. So this would be directly across, and the bromo would be BR. So folks, there you go. Now, some of you are probably going to say, well, how did you know to write the OH up at the top? Well, I don't. You can actually start anywhere with that. So I could put my OH over here to the left. That's perfectly fine, as long as you put a para position on it, which means directly across from it, there should be a bromo group. That is also p-bromophenol. There's no difference in these two structures. I'm just making this structure match the template that I have done up here because I get the freedom to do that. They're telling me to draw the structures myself, and that's just the way that I've set up the problem. All right, so for part C, they're going to give me ortho, nitro, aniline. Oh, okay. So I'll start with my benzene ring. Aniline. What is aniline? Well, hopefully you remember that's an NH2 group. So there is the aniline structure. And ortho to that position is going to be a nitro group. So O, and that's an NO2 that's going to be present. All right, so for part D, M, chloro, benzo, nitrile. All right, so let's answer this one. So benzonitrile is a benzene ring with a C triple bond N up at the top. There's my nitrile group. Well, meta to that group is a chloro group. So OM, and this needs to be a Cl. Folks, there you go. That's all there is to it. I know that you're getting these right. I know that you're getting these correct. You're probably looking at these and saying, psh, do you have anything more complicated for me to do? That's what you're asking me. I know it is. All right, so for part E. E says M dichlorobenzene. All right, so here is my ring structure. I'll start with one chloro. We'll put it there. OM, there's the meta, and there's my second chlorine. Oh, there is to it. It took me like seconds to answer. Seconds! That's all that it takes, if you know what you're doing. All right, so now let's do F. F is going to be O-xylene. All right, so xylene's one of those common names that we talked about earlier. We said that we didn't see this in the first round, and the reason is because xylene is the common name for a benzene with two groups on it, and those two groups are methyl groups. So I need to make sure that this is ortho to each other. So here's my first one, and there's the first methyl. So ortho to that would be there. So I'll put another methyl group that would be in that second position. So there's ortho, or O, xylene. Okay, once again, well, why did you draw it to the right-hand side? I always have those questions, and I didn't have to, folks. I could have easily drawn it over here to the left, and I could have put my methyl group right there. That's perfectly okay. They're still ortho to each other. It is the same molecule. All right, so there's our example problem that we left off with here, and now we've seen how easy it was to answer questions A, B, C, D, E, and F. Now, you know how I work. If you've had me before for Chemistry 251 or for another class, you know that once I get you kind of comfortable, I push again. And I'm getting ready to push you one more time. Because guess what, folks? These types of example problems, we don't have to stop there. Oh no, what does that mean? What's he getting ready for me to do? Nothing new. The only thing that I want you to do is be comfortable with something like this. If I can put two groups, I can put three groups on. And we should be able to use our IUPAC nomenclature rules in order to name that structure. There's no difference there, right? I mean, I just have another group in order to put into this name. So as far as the basic rules go, folks, it's all the same. It's all similar. Nothing new that I'm getting ready to present to you right now is going to happen. These are the same IUPAC rules that we've talked about now for a semester so far in Chemistry 251 and half of a semester in Chemistry 252. So how can I come up with the name of this ring? All right, the only thing that we have to do here is keep in mind total lowest group number, which means back in the day, maybe just one or two videos back, this was called a bromo, this was called a chloro, and this was called a nitro. It's still called the same thing. No difference. And now when I look at this, if we use the rules to the past, we said, oh, well, bromo comes first because alphabetically it comes first. So I'll put my one, ding, right there. And if you do that here, it's going to be wrong. And that was because before we were only comparing two groups with each other. But now we're comparing three groups. There's more to the table, more to the party for me to entertain. Who's got time for all of this? And I'm talking about organic too as well. Who's got time for all of this? So if I take a look at this benzene ring with these multiple groups, I still do write them in alphabetical order. I don't want you to misinterpret that. I'll still write bromo first, and then I'll come in and write chloro, and then I'll come in and write nitro, and then I'll write benzene at the very end. That is the same. I still write them in alphabetical order. The difference is that before, when we only had two groups, alphabetical got one, and then we numbered the other one accordingly. There was no priority here. Well, there's still no priority, meaning one group doesn't beat out the others just basically on how it's defined. But what does change here is that I have a cluster of groups over here together. And if the name of the game for IUPAC is lowest number possible, then I have to make sure that stays true. Meaning, I need to number the ring such that I provide the lowest numbers as much as I can. So the only way to do this is start nitro at number 1, then bromo at number 2, this would be carbon 3, and chloro would be carbon 4. If I number this any other way, maybe bromo at number 1, nitro at number 2, the next carbon would be 3, the next carbon would be 4, the next carbon would be 5. That gives me a higher number. It's not going to work. If I start at chlorine and do that one as number 1, that carbon will be 2, bromo would be 3, nitro would be 4. That gives me higher numbers as a total in the very end. It's not going to work. So this is my only option in order to give me a 2 bromo, a 4 chloro, and then a 1 nitrobenzene. Now, some people will take this 1 and they will leave that off. That's nothing new, because we've always said if there's not a number that is present, it's understood to be 1 if a number needs to be kind of understood. So 2 bromo 4 chloro nitrobenzene would work. 2 bromo 4 chloro 1 nitrobenzene would work. What about ortho bromo nitro chlorobenzene? No. No. You can't do that mess. Nobody said you could do any of that. So the ortho, the meta, and the para. Folks, these are only good when you have two groups that you're trying to compare together. That's it. If you have 3 groups, you cannot do OMP on those molecules. You just can't. There's no way that we can bring in a proper name and use OMP to describe 2 of the 3 groups and give the other one a number. Can't do that. Not going to work. All right, so let's do another example using the same grouping just so I can really hit home a message. Let's put my BR there. Let's put the NO2 group here. And let's put the Cl group here. Name it. Okay, well, we'll use the rules that we've understood already. We hope we understand them, right? And I know that bromo is going to have to be written first, and then chloro is written second, and then nitro gets written third with the name benzene. So that doesn't change. Alphabetical order, there we go. It's always been alphabetical order. But I've got to figure out the numbers that go here. Now, the previous example was a little different. The groups were located in different positions. Doesn't matter. No group gets priority over another group unless it's part of the name. So, what that means is that on this ring, it looks like I have a cluster of groups on this side. To provide the lowest number possible, 1 starts there, 2 goes here, 3 goes there, 4 goes there. Any other way that you number that, you're going to give me higher numbers for those groups. Again, always the same rule for IUPAC ever since day 1. Ever since day 1 in Chem 251 was this the case. So what that means is that chloro will get a 1 position, nitro would get a 2 position, and bromo would get a 4 position. So this one is 4 bromo, 1 chloro, 2 nitro, benzene. Folks, look at this. This just basically, again, hits home a message that it doesn't matter the groups. We're focused here on lowest numbers possible. All right, so now I'm going to come and do a third example for you. Here's a benzene ring. Let's put my Br here. Let's put the NO2 group here, and let's put the Cl group there. How would we name this one? Use the same rules. B, bromo's written first. C, chloro's written second. And then nitrobenzene. Okay, so there's that part. Got to figure out numbers. It looks like my cluster is over here. So I probably need to start over here with a 1. And it looks like that bromo is going to get the 1 spot, and nitro would get the 2, that would get the 3, and this would get the 4. If you number any other way, you'll get higher numbers. If you don't trust me, then do it. Compare those answers. See if you can number this ring to give me an overall lower number in the name. I bet you can't. So that means that in this name, 1 goes for bromo, and then the 2 goes for nitro, and then the 4 goes to chloro. Folks, look at this. Same groups, same benzene ring. They're just positioned on that ring in a different way. They are named the same as far as alphabetical order goes, but the numbering is different in each case. And that's because I did not give a group a priority number, right? One does not outweigh the other. The only thing that is driving this decision is lowest group numbers in total. And that is it. And that is how it will always be in here when we talk about benzenes that have more than one group on them. All right, now that I say that, I want to give you a few exceptions here. You should know they were coming. So here, let's do a C double bond O OH. And here, let's do an NO2 group. And then here, let's do a Br. Okay, let's name it. 3 groups, not a big deal. We've talked about how to name things with 3 groups. It doesn't seem very difficult. So let's see if we can kind of put our money where our mouth is. Well, this is called a nitro. All right, so I'll write that down. This is called a bromo group. I'll write that down. What's this called? C double bond OOH. Well, that looks like a carboxylic acid, Tracy. We learned about that in Chemistry 251, and I know carboxylic acids are pKa values of 4-ish, or a little bit lower. They're acids. They like to spit off a proton. Okay, yeah, I know, but did we ever name them? And the answer is no. We never really named carboxylic acid groups C double bond OOHs. But we do know that in the list that I told you to memorize, we have a name that can take care of the benzene as well as the C double bond OOH all at one fell swoop. This is nothing new. We've talked about this with di-substituted benzenes. And we said that if we can bring in a name that can take care of that whole thing at one time, then we'll use it. Okay, this was called benzoic acid. There you go. Now, because I named it benzoic acid, that means that this C double bond OOH group, that has to be by default carbon number 1. Now it's up to me to start there and figure out lowest group numbers. It's still the same game. Lowest group number possible. How do we do this? Well, do I go counterclockwise and go to bromine first, or do I go down and go to the nitro group first? If I go down and go to the nitro, this will give me a 2 position, a 3 position, a 4 position, and a 5 position. That would be the lowest possible number arrangement that I could come up with. So in the name, this is going to be a 5 bromo because B comes first. and then a 2 nitro, and then I could squeeze in a 1 benzoic acid if I wanted, or I can just leave that off and it's understood to be there. So 5 bromo 2 nitro benzoic acid. That is the name of that structure. All right, let's do another. Here we'll have a benzene ring, and I have a chloro, and a bromo, and an OH. Name it. Okay, well, if I learned the rules as before, this is going to be called a chloro, and this is going to be called a bromo, and this is going to be called an alcohol. But I never really talked about how to name an alcohol in a ring. We've only named alcohols in straight chains. But there is a common name. There is a common name on a benzene ring. We know that. That was part of the list. I told you to memorize it. Blah, 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 blah. So, this benzene ring with that OH group has a common name that we can use to take care of both, and that's called a phenol. All right, now in doing that, that means that this OH group by default has to start at number 1. Now I need to look at this structure and figure out how to give you the lowest number possible. Do I go clockwise and go left-handed? Or do I go counterclockwise and go right-handed? And the only answer to this is spot number 2 is here, spot number 3 is there, and spot number 4 is there. So in the name, I'm going to start off with bromo because B comes before C. I hope we know that. So 3 bromo, 4 chloro, phenol. And there's your name. All right, let's do another one. See, I told you, this wasn't that bad. You thought that this was going to be a disaster, and you're like, oh no, just when I learn something, he goes behind and he changes it. No, we've not really changed anything at all. You know, we just added a step. That's all that we've done with these. So here's a benzene with 3 groups, yet again, and I've got to figure out how on earth do I name this thing? Okay, well, the I know is iodo. The NH2 is an amine functional group, but how do we really name it? And then the CH2CH3, this was an ethyl group. Well, as before, we know from that master list that I can take care of the benzene ring with that NH2 group as long as I name it as an aniline. So there is the aniline structure, and by default, that is carbon number 1. How do I number? Well, as you might suspect, we're going to go counterclockwise. So what that means is that this carbon is number 2, this one's 3, and this one is 4. So in the name, E comes before I, so that means this is a 2 ethyl, and then a 4 iodo aniline. Once again, if you want to put a 1 there, feel free to put a 1 there. Doesn't matter to me. But if you want to leave it off, it looks a little bit more proper if you do, and provide me 2 ethyl 4 iodo aniline, then you've got a correct answer. Ding, ding! You got it right. So let's take a look at an example problem. Oh no, another one. Yeah, another one. And this one is going to involve more than 1 or 2 groups. Almost in every one of these cases, we're looking at 3 groups that are on a benzene ring. It says, draw the structure for each of the following. M-chlorotoluene, P-bromophenol, O-nitroaniline, M-chlorobenzonitrile, 2-bromo-4-iodophenol, M-dichlorobenzene, 2,5-dinitrobenzaldehyde, and 4-bromo-3-chloroaniline. That's a mouthful. That's a foreign language. Look at this. I mean, imagine giving this to someone enrolled in Chemistry 151 or 152 or even in 251. Could you answer this? Could you even say those words back in that day? If not, and you can now, you're learning. And that's part of the class. You're learning organic. Look at this. We're on a roll. We'll keep it up. So in the next video, we'll pick up from here. Try each one of these before you hit the play button. The people that try these example problems on their own and then use the videos as a check to make sure that they are doing these the proper way always seem to do better in lecture and on the test. So please try these on your own, see what you come up with, and then in the next video, we'll double check these answers that you have. So A through H, good luck, and I'll see you in a couple of minutes.